6.13. I am on page 81, so go ahead and turn to 81. Again, we haven't really done too much with tangent, but you're seeing a lot more of tangent now. Here, I want you to just use your unit circle. Identify what the tangent is at pi over 6, 5 pi over 6, 7 pi over 6, and then all the other ones. Practice using your unit circle for tangent, please. As we are progressing through this second quarter of this semester, you're going to have a couple more unit circle quizzes, and I might give you one on a chart, and I might ask you to find tangent. So please make sure we are starting to work on tangent, and nice job those of you who have already been working on tangent, because you've been adding it to your unit circles. So very good to you. And I did check them to see if you had them correct, so good job, because if I didn't circle anything, you had it correct. All right, now this is kind of wrapping up our module. It's also starting to prepare us for Module 7, but we're not going to get to Module 7 for quite some time, so I'm not going to put a whole lot of emphasis here. But this is a great place to just look at different equations, changing things. You are being asked to graph a whole bunch of different things, different functions that it's been a while. Here you want to write the new equation with the given transformations, and then you're going to sketch the new graph. It might be easier to sketch the graph first. Vertical, okay, that's the up or down. Horizontal is the left or right. And then a dilation is making the graph wider or smaller. So it's the same through all of these. I don't want to spend a lot of time here. Excuse me, a lot of time here. We're going to come back to this stuff regardless. Now, number 4 is a sine-cosine graph, sine graph. Maybe work on this one. If you're going to skip anything, skip 1, 2, and 3 and work on number 4, please. It's good practice. It's also really good practice, all of these, with the domain and the range, you guys. It's been a while since we've done domain and range. All right. Now to the set. Again, we're wrapping everything up here. They're giving you some information. Like here they're telling you this is 1. You're finding side lengths. Go for it. Use Pythagorean theorem. Look at what these mean. Remember what these mean about the congruencies, maybe. Use your knowledge of right triangles. 6, go ahead and see if you can find the lengths of the triangle. It wants you to use the information in the figure to label the lengths of the sides, RA, and the exact length of SA, and it wants angle measures. Again, you're given one piece of information. You're told that this is 1. You're told it's an equilateral triangle. Challenge yourself with both of these, because you're only given one numerical piece of information, but you're also given other things that will help you find angle measures and side lengths. And you're going to go back to your right triangle trig, SOHCAHTOA, sine and cosine and tangent. 7, I would like you to use your unit circle. See if you can remember it before your unit circle, though. See if you could fill these in, because this is similar to what you would have to do with Renesas when you guys get to calculus next year, as far as filling it in on a chart. See if you can use your unit circle to just check your answers. Try not to just cheat and use your unit circle. You could also use this circle here to start filling in, if you guys want to, as a way to practice your unit circle. You are finished and you have nothing else to work on. Come back and work on this unit circle. Fill in degrees, radians, and your cosine and your sine, your x and your y. Fill those in. That is our unit circle now. Take the time. Practice. Please practice your unit circle. You're going to answer some questions in 8, 9, 10, and 11 Please read them. Name the angles of rotation in radians where sine equals 0. Use your unit circle if you need to. There's nothing wrong with looking at your unit circle. Name the angles of rotation in radians where the sine is 0. Let me give you the first one. The first angle in radians where sine is 0 is 0 radians. Now you can go from there. There's a couple others. You want to find where is cosine 0, where is tangent 0, where are they undefined? You're just identifying in radians, 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 radians. You're welcome to graph tangent if you want to. You can type this into Desmos. You could actually use your unit circle. What is the tangent at pi over 2? What is the tangent at pi? What's the tangent at 3 pi over 2? What's the tangent at 2 pi? You're welcome to challenge yourself. Sorry. I'm tired. If not, I'm not worried about you guys graphing tangent right now. That could be something that we do on Friday or Monday. Or you can ask Mr. Rivas if you really, really want to, if you guys have time. And then the go, this is, again, review. You're answering questions. And please answer with justification. Don't just give me quick 1 or 2 word sentences. Really justify it. Given that, oh, hold on. All right. Given that triangle ABC with an angle CB in the right angle, what is the sum of the measures of angles A and B? Don't just say that their sum is 90. Explain why. If you can explain it, you really know it. Please give me a brief explanation. So 90 degrees. And it could be something, well, you can say 90 degrees back here also. You could say something along the lines of there's 180 degrees in a triangle, and if one of the 3 angles is a right angle, there it is 90 degrees, and that leaves 90 degrees for the other 2. Something like that. That was a lot of words, but some kind of justification for everything. And we're really struggling with that right now. So justify things. So that's what all these are. You're just answering the question and then justify it. Provide mathematical justification. And that could be a sentence explaining something. You don't have to show 2 + 2 is 4. All right. That's it. I will be back on Friday for periods 1 through 4. And I will see the rest of you on Monday. Come ready with questions. You have a test on Tuesday. And I will see you later.